apologize. Technical difficulties. So today I will also have Jeff Garbus, our CEO, Eagle, presenting, as well as Andy Cook from Cominario as one of our guests. And again, I'm having technical difficulties moving my slides.
Royce did not log in as a presenter. That's why he can't move the slides.
I apologize. Can you move me to the next slide then, Jeff? So a little bit about me. I am the Director of Sales here at Soaring Eagle. Been here for a little over 3 years. And one of the things that I like to make sure that all our customers know is that I'm always here for them. I'm just a phone call away. I'll move on to the next slide, Jeff. All right, so a little bit about Soaring Eagle. What we do is we ensure our clients' data is accessible, maintained, and performs well. We do this with highly regulated industries such as healthcare and financial institutions. So as you can see in the slide, there's a lot of things that we do, but I want to tell you a little bit of a story of how it is to work with our team. A while ago, our CEO, Jeff Garbus, was asked to go to a client site where the environment was filled with people and the hair was on fire. A lot of tension in the ranks. The CEO of the company alone was about to fire the whole IT staff and sue the vendor itself. When he introduced Jeff, he introduced him as the person that was going to come in and replace their jobs, and obviously caused quite a bit of dissension amongst the ranks. Jeff did work with everyone in that room. He found the core issues. He came up with a strategy to fix them, and obviously relieved a lot of the stress instantaneously as he worked with them. By the end of the day, everyone was relaxed and they were friends again. So he was able to go in, and truly just work with the team. Now, at the company, our company did lose the project at the end of the day, but we did help them out. But the most important piece is we gained a relationship with the vendor and the client that lasted over a decade. So the moral of the story is Soaring Eagle is here to support your team and work with you, and not to work against you and bring synergy to the table. Moving to the next slide is can you move to the next slide, please?
I have. Is it not showing? I guess we're back to technical difficulties. Show application is paused.
Perfect. Thank you. That's my slide. So why is 10 seconds too slow? So talk about the fact that slow applications hurt businesses' bottom lines is, ultimately why we're here. Clients complain about applications. They stop shopping. Manpower costs and users sitting around waiting for applications and reports to load cost companies tens and thousands of dollars a year. A little quick story of something recently happened to me. I was actually shopping online. I was looking for a new set of doors for my house. I had some projects going on. And ultimately, I was looking, and I couldn't get the website to load its page, and it just kept, blocking out on me. And obviously, I'm too impatient. 5 seconds was too long for me, so I went and looked somewhere else, and ultimately bought from a different company, and that was, $2,000 in itself. So just imagine if you take just me, just one shopper, and you multiply that by hundreds of shoppers in an hour, it's costing business a lot of money on the bottom line. So ultimately, Jeff and team is going to get together and really, dive deeper into this. So moving forward, let me introduce you to Jeff Garbus, our CEO and founder. He's written over 20 books, hundreds of articles over the years. He used to teach at Microsoft. They used to use his materials. Founded Soaring Eagle in 1997. He's a hands-on type of guy, 30 plus years in the IT industry. He does performance and tuning, scalability, anything he can do to work with the team. But the thing that's most impressive about Jeff, I mean, there's a lot of things that are impressive about Jeff and his dynamic speaking, but every time that he, as the client quoted here, every time you were in our lab, you provided benefit to our team. That's from one of our customers, Eric Nielsen over there at SSI. And that's not just how he feels, that's how any customer that he is interacting with feels about Jeff. That's just who he is. So with any further ado, I want to turn it over to Jeff Garbus.
Thank you very much, Royce. Again, my name is Jeff, and I am a performance geek. So I'm going to spend the next 15 or 20 minutes talking a little bit how to identify performance, what the benefits and detractions are in your system, how you can identify what the root cause of the problem is. Because what ends up happening a lot of times is people will complain, and management will throw hardware at a problem, and the money will get spent and the complaints don't get resolved. So issue number one is root cause analysis. But let's talk about what causes people to complain. So performance can be defined in a lot of different ways at a lot of different shops. So sometimes it's query response time. Royce was talking about interacting with a web app trying to place an order. Sometimes it's overall user interaction time. So customer service reps will tell you on the phone, hang on, our system is running slowly today. And they probably say that every day because it's not an erratic thing. Performance is just dragging some places and needs to be addressed. Other places it's, well, we've got a 6-hour batch window and we're now taking up a 5 3/4 hours and we're worried about what's going to happen later. A lot of things can drive the complaints about performance. And what you have to be able to do is identify what the root cause is. So when I get called in, it's frequently because people are saying we have performance problems, and I always start with, how are you defining performance? What is bad performance for you, and where does it need to go? Frequently, by the time I'm brought in, people have a dedicated room. Sometimes they call it a war room, and sometimes it's just a conference room that nobody wants to go into, to have a finger pointing session. This finger pointing session involves the application folks saying it's the database saying it's the application, the network people saying, well, everything looks normal to us, the SAN people saying, well, the storage is running well below capacity. And we need to identify what's going on. And sometimes there's a little bit of right for everybody. Sometimes there is a problem with the application. Sometimes the database needs some tuning. Sometimes the SAN people don't realize that they've got one LUN out of 100 that is running at beyond capacity, and the rest of them are sitting still. The SAN is showing that everything is running well below capacity because overall it is. So identifying that root cause becomes our target issue. So let's take a look at identifying performance issues all by itself. These numbers are a combination of a Gartner group. There are a few other groups that we have borrowed these numbers from. Some of them are internal Microsoft numbers. So as you start looking at performance issues, think about what happens when somebody has a performance problem. They'll call the help desk, say things are running slow. Again, Gartner group number, the average calls by the help desk person to figure out who even has to address this is 6. All of a sudden, one performance issue involves 6 people. On the average, industry-wide, IT spends about a quarter of its time dealing with performance issues. This number is an internal number that the third number, the 30, is a number that I got after buying a couple of beers for some people from a load testing company. They were in at a client site of ours, and the question was, okay, if we use the load tester, are we going to find everything we need to? And they say that internally they hope to find 30% of the performance problems before things roll out. That, by the way, is why I get a lot of time babysitting applications at rollout time. 70, this one's a Microsoft number. 70% of performance problems are caused by source code, not by infrastructure. 73, this one's a Gartner Group number, percentage of performance problems first reported by business users. And 80 is an experience number. This comes from multiple groups. There are lots of 80-20 rules in IT, and this one in particular says that the mean time to resolution to finding the problem is about 80% of the elapsed time to resolve the problem. So one of the things that we like to do, if we can knock off that 80% with, say, a good tool, and I'm a big tools guy now, that is a multiplier 5 times faster to get to the end result. As far as performance goes, I'm often reminded of that line from Roadhouse, if anybody's seen it. Patrick Swayze's calling his buddy because he's in a little bit over his head, and his friend says, "How's it going?" And he says, "Well, same old, but it's amazing what you can get used to." And people are like that a lot. Well, yeah, we're getting 4 or 5 second performance, but that's what it's always been, so everybody gets used to it. And to me, you need to think outside the box a little bit and start asking the question, can we make it better? This first case study, and by the way, these are both real-life experiences that we've dealt with. In this first case study, we got called by an internet vendor of printer cartridges who said, "Jeff, we have 9-second performance. We're losing customers because it takes so long for people to do lookups on our website. Our marketing team has told us that we will net $75,000 a month more, and their margins were not high, so that's a lot of sales, for every 1-second improvement in performance." Well, my first question, of course, was, well, can I have a cut rather than a monthly fee? Pay me 10% of what I make you. And they said, no, we'll pay you on a daily basis just like everybody else. And I pouted, but I fixed their problem. We dropped it down to 1/4 of a second per query. We did that within about a day or two. And once again, this directly drives performance because people, if you ever look at a 2-year-old, 2-year-olds will either stick with a problem until it's solved or until they scream and throw it against the wall, or they'll stick with it for a couple of seconds and move on to something else. And a lot of people who shop on the internet, or even just people working with computers in general, the same. They have the minimal amount of patience because they have this expectation that was set years ago that everything has to happen sub-second. Second case study was a group that we got brought into. This is a very, very large public company, and 3,000 on-site customer service representatives gives you the scale of the size of the company because this was one small part of what they were doing. So the customer service reps were downloading about 30 days worth of their own schedule on a nightly basis, 30 days moving forward. And this was taking over 30 minutes and sometimes simply timing out, meaning they have to start this process all over again. We went in, we dropped this time to less than 2 minutes. And there's a funny story behind that because the organization did not tell the customer service reps that things would be getting faster because they did not want to set an expectation and then blow the expectation. So when their 30-minute download came down to less than 2 minutes, they got 3,000 telephone calls in one night, and they did tell me that was the best 3,000 telephone calls they ever got. So the idea behind performance and tuning is not just throwing hardware at a problem, not just getting it resolved quickly, but understanding where the basis of the performance issue is, justifying the business value in improving performance, and then moving forward. So first step in solving the problem, identify it. I have lost track of the number of times that I've been brought into an organization because they chose to spend some number of $1 million on a problem in hardware, and it had zero effect on the problem. If your problem is disk speed, then throwing CPUs and memory at the problem are probably not going to help. If your problem is that the queries are bad, throwing CPUs are probably not going to help. If your problem is network infrastructure, that you can go through these as long as I can, but people do frequently solve the same problem or attempt to solve the same problem with the same wrong solution. So we're going to assume for the sake of the next several slides that you have positively identified that the database is an issue. And honestly, by the time I get called in, this is frequently the case, that they have narrowed it down to the database and thrown up their hands and say, what do we do now? So as we look at this, we're going to look at either resources or the DBMS, so macro scale versus micro. From a macro scale standpoint, is the problem that we simply can't get the data off the disk fast enough? Is it that I need more memory? I did have a customer recently where we identified that about a third of their elapsed time was getting the information off the disk, and about a third of the elapsed time was making space in memory for the information to come in and become available. So when we brought in faster disk, they immediately got that 30% benefit, and we threw memory at it subsequently, they immediately got the other 33% benefit. So you can watch these things as long as you quantify them and you have a tool to measure it. At the micro scale, at the DBMS level, we're also looking to say, what about the queries? Have we written the SQL badly? Is it the DBMS using a bad query plan? Are we missing indexes? And by the way, that's the single best way of looking like a genius is to find the right index, put it in, and have a multi-hour query come down to a couple of seconds. So before making the decision to get new hardware, what we recommend is start looking at things at the DBMS level. Fix the problem first, then go for more hardware. So this set of slides is using a Microsoft SQL Server as an example. The approach is about the same regardless of the DBMS you're using and regardless of the platform you're on, whether you're on premises or using Azure or using AWS, doesn't really matter. What you have to do is identify where the specific problem is. Where is the bottleneck? So in the olden days, what we would do is we would interview the users, talk about which applications were slow, what buttons they would hit. You could run the profiler, identify what queries are running. On Microsoft SQL Server, by the way, Microsoft's internal numbers say that running the profiler full out can use as much as 70% of your CPUs. So we would identify some problems, we'd fix the problems, and then we'd go through an iterative process of identifying where the issue is. I do like the concept of monitoring this so that you're not sitting there staring at the box waiting for a problem to happen. If you put a monitor on your system, then what you find is, and by the way, these are all findings that I have spent a lot of time resolving. Sometimes it's just a single query, and the single query is not the one that you think is a problem. It's taking a little over a second. People are fine with a little over a second. Well, they're not fine with it, but they don't complain about it because they know that you won't pay attention when they complain about other things that are more important. These types of things can equate to most of your CPUs. So something that's running 1,000 times a second, if it's in 1.2 seconds, that might be a lot of your CPU. If you can knock that down to, say, 2 milliseconds, all of a sudden you get a lot of your CPU back. You may find that most of your users are spending most of their time waiting for locks to be released. My record for that is I walked into a shop where 80% of the users were sitting in lock wait time for over 20 seconds on the average. Well, guess what? We eliminated the blocker, and it was a single index, but all of a sudden the calls started coming in. Did you fix something? All of a sudden everything is faster. Well, this is a perceived performance issue because blocking is normal, but we did not have to add resources. We simply needed to identify where the problem was. And sometimes you find that 4 or 5 queries using the same tables, the same wrong indexes, blocking each other, get some index recommendations. So how are we going to fix the performance problems? Sometimes this is hardware. This often masks the problem rather than resolving it, unless you've positively identified hardware as an issue. I've also lost count of the number of times that I've walked into an environment. They have thrown hardware at the problem already. It fixed it for a little while, and then the problem came back and smacked them in the back of the head 10 times harder, and it was that much more difficult to, A, justify having spent 7 figures on hardware, and B, try to figure out what the problem was while everybody's hair is on fire. Sometimes you can reconfigure the server. Sometimes you can rewrite bad queries. Adding indexes is one of my favorite because it's non-intrusive, and the trip through the QA department tends to be a lot faster than when you're rewriting the queries. But once again, you have to identify the problem where we get in order to get there. So I used to, and Royce mentioned I've been doing this for about 30 years. I was first certified to teach performance and tuning for SQL Server and Sybase back in the late 80s, and that was back when you had to have actually done it before you could get certified to teach it. So lots of scripts, lots of ways of performing this that I've done on my own. I finally came to the conclusion that there are enough tools out there that do a lot of this work that rather than dealing with the continual, seemingly new versions of software that are coming out, rather than rewriting all my own scripts, I let a vendor do it who had the scripts that are there. So what am I looking for? Here's a short list of what I'm looking for. What queries are hitting the server the hardest, taking up the most elapsed time, using the most resources? Is there a lot of blocking going on? Are there specific resources that are getting hit? And if so, can we measure what's happening at that individual resource level? So what I do is I start looking at these types of resources. So again, this is SQL Server and this is Windows, but you'll be performing the same types of things if you're on a Unix environment working with Oracle or Sybase or MySQL. So look at memory. Memory takes up two different types of aspects. One is the paging. You want to avoid memory paging if possible, particularly for Windows-based applications. This red circle was an indicator of where we had dropped the memory by a lot by making a couple of changes, namely here adding memory to the server. You can see that the lines went down a lot. So skip that memory paging. Next is physical disk. Now, after I've tuned queries and added indexes, if I still have a disk queue length issue, there is a physical SAN performance problem. And what ends up happening sometimes is you get into an environment where they say the SAN looks fine. You say, fine. You say the SAN looks fine, but what I'm seeing here is a graphical indicator that we are not getting the information off the disk as fast as we're requesting it. So if you look at the Microsoft internal numbers, it tells you that you want your disk queue length to be 2 or less. If you've got 2 or more, and that lasts for a period of 10 minutes, you have an I/O bottleneck. So when you see that these things are spiking over the course of 10 minutes up to 200, that's an I/O bottleneck. And clearly 200 is greater than 2. So once you're tuned, if you're still saying these, it's time to look for faster storage. Another good thing to look at is things like blockers. Blockers and blockchains are a great way of identifying a perceived performance issue. And when I say perceived performance issue, I mean that the server itself is not running slowly. It's that the people are not getting access to their data because something else has got a lock sitting in front of it. Note that locks are generally created by applications which are transactional, and those transactions can be speeded up in a variety of ways. You can break the transactions up, you can add indexes, depends on the transaction. Another one that is nice to be able to identify, and this is one that is relatively new, particular to SQL Server, and it is well documented, and therefore it is a feature and not a bug. And that is that as you start adding space to a log file in a database for Microsoft SQL Server, what ends up happening is each time you add a chunk of space to the log, you add additional virtual log files, 4 virtual log files. Without going into a 20-minute explanation, this problem is caused by the auto increment of the log where the auto increment is set too low. If the auto increment is set to 1 meg and you grow it up to a gig, then you're going to end up with 1,000 of these auto increments and 4,000 VLFs. The catch is more than 20 tend to cause a performance problem because the server at runtime looks around for a place to perform the write in the log so that it doesn't end up with a contention issue. So the act of trying to avoid contention creates a lot of wait time trying to avoid contention. It's just the strangest sort of thing. But the bug is still out there, and the solution is relatively simple. You drop and recreate the log all at once instead of in 1,000 little bits. But having a tool that allows you to pick this up and deal with the issue and identify that it is an issue because you got a lot of log weight makes your life easy. Another good thing a tool does for you is pick up trending. So when you ask questions like, do I have a physical database performance problem? Is this something that's happening over the course of an hour, a day, a week, or is it just simply an occasional spike? So if there's an occasional spike, we tend not to worry about it. But if this thing is dragging out over the course of hours or days, or 3 o'clock to 5 o'clock p.m. is always horrible, then we're going to have to go in and address it. Network issue is another thing that I find the network people always say the network isn't the problem. The problem you run into is that sometimes the network is a problem. You may find that people are sweeping backups across the network during the day. You may find that there is a hardware glitch that nobody's aware of. One of my favorite problems to identify was a place where everybody said the network is running fine, but when we went in there, we found that the round trip time from the box out to anything even nearby was taking nearly a second to a second and a half. The problem was they had a bad network card on the server, and it was kicking back 98% of all the packets. Well, you multiply 50 times whatever the work has to happen, it's going to be 50 times slower across the network, which we always presume is going to be a bottleneck anyway, and presto, got a problem. So be aware of the network lag times that you should have in between your boxes. You also need to be able to take a look at the queries and tune the queries. After I look at resources, this is the place I come next. The reason for that is if I'm just simply crazily I/O bound, I want to know about it because then I want to find out what queries are hitting storage. If I am crazily CPU bound, I want to find out which queries are hitting the CPU, and I'll start there. But in general, any query that's running a lot is something you want to take a look at. Take a look at your heavy hitters. A good tool will allow these things to bubble down and give you the ability to say, this query up here is the one that's causing the most physical resources to be used, so we're going to start looking at that one first. Finally, great thing about a tool, historical information. It looks like this query was taking about 700 milliseconds on June 25th, 600 on the 26th, made it a little bit faster on the 27th, then on the 28th, guess what? We suddenly got really fast. So whatever it was that we were tuning, we can take a look and verify that the actions that we were using to tune has a positive effect. This is critical as part of your tuning effort. Back to the network, what about if we're sending too much data across? We have the ability to identify that this data is actually crushing our system. What about executions? We have 34,000 executions in an hour versus one execution in an hour. Well, if that one execution is a one-off, we don't spend a lot of time tuning it. It may not run again. It's running 34,000 times an hour. We'll spend a little bit of time on it. So how do we tune? We identify low-hanging fruit. We demonstrate value with a before and after picture. Love the before and after pictures. Note the scale. There's 160 seconds versus now the slowest thing is taking 5 seconds. Great way of taking a look at it. This is also a favorite picture from a client gig that I did just a couple of years ago. So what do we do in terms of site visits? Royce talked about going on to particular sites and making friends. We try to do this really hard, and every once in a while we say, you know what, your people are great, they're smart, but they've been doing this for 2 years. You're trying to deal with petabytes of information. You really need to bring in somebody who has dealt with this volume, this scale, has dealt with high availability. We'll recommend managed services. This particular site was interesting. The team said we can do it ourselves. The CIO said, I'm going to trust my team. We made a social visit in there, and the CIO said, you know what, Jeff, I know this is a social visit, but can you please go talk to, I won't mention the name, they're having problems, been going on since yesterday, and they're just stuck. So in the span of a couple of minutes, we identified 5 immediate issues to resolve, and these were all outside the knowledge base of the current staff. After talking through this, I mean, this is just really less than 5 minutes, the CIO said, Jeff, I get it now. We do need somebody to look at this who understands where to look, what to look for, and what the problems are as things scale. So this is a very common type of thing for us to do, to come in when things are hitting the fan. Now, why would a group say we don't want help? Sometimes people are a little worried about their jobs. I don't want Jeff to replace me. We've got no interest in doing anything like that. Sometimes it's I'm brand new here and I don't want people to know that I don't know all of these things, even though they weren't necessarily hired as a guru. They were hired to do some basic administration. Sometimes you simply can't find the right staff. When you're in New York City or Tampa, you may be able to find a very sharp DBA with a lot of experience. If you're in the middle of, I don't want to use any phrasing that's going to offend anybody, but if you're out in the outskirts where you're in a town with a population of 17,000 and not a population of 17 million, it might be harder to find a very specific skill set. So breadth of knowledge, depth of knowledge, very important things to be aware of as you're bringing your team in. And if you do hire one, what happens when that person goes on vacation and leaves a cell phone behind, or her cell phone behind? DBA as a single point of failure is something that people have dealt with over and over and over again, and one of the other types of things that we want to fix. So as we start getting past query issues, things that can be resolved easily, we do get to the point sometimes where we do identify that storage is the problem, and that's the only way to fix the problem. We take queries from 20 seconds down to 6 seconds, and at that point, all that 6 seconds that's left is waiting for the disk to respond. At that point, what you need to be able to do is say, all right, it's tuned, we've watched it, we do need to go from 6 seconds to sub-second. Now it's time to get in there and replace the storage. People ask me, what storage do I buy? And I've said, well, flash, solid state, and I've dealt with lots of vendors over time. And what I've found is a lot of vendors are extraordinarily high priced, and they tend to price things based on how much can you afford to pay as opposed to anything else. So I've identified a storage vendor that we really like, and that's Combinario, and they're going to be speaking next. And we picked them out because I think they have the best technology, and they have great speed, and they take really good care of my customers. The companies that we've brought them into have all bought more after making initial purchases, and to me, this is a great recommendation because they see the value, they identify the value, they demonstrate the value, and over time, they trust it and they bring more in. So I'm going to move this next part of the presentation directly over to our next speaker. But as he's talking, I want you to take away a list of things that are really important to look for in a flash storage solution. This is my own list in order of the things that I think are the most important. First is adaptive block sizes. With a lot of the flash storage solutions, you will have to configure it and say 2K blocks, 8K blocks, 16K blocks. Thing to be aware of is that when you are storing things in 2K blocks and retrieving them in 8K blocks, which is what SQL Server wants to do, you suddenly have 4 IOs per request. That means that your 200,000 IOPS is now suddenly effectively 50,000 IOPS. I like data encryption at rest to be automatic and part of the hardware, so they don't have to pay separately for it. And this is absolutely critical to maintaining things like HIPAA compliance, things like Sarbox compliance, and it's going to get a little bit worse. You want your performance to be predictable, not erratic. You want the compression to be automatic and smart and something that you can control. You want this to be easy to use. You want plug and play. You don't want to have to buy a new SAN team for your storage. You want the pricing to be reasonable, the warranty to be effective, and you want upward and outward scalability. These are all things that you're going to see in the next several sets of slides as I turn things over to Randy. So these are some quick numbers that we saw from presenters. I am at this point going to turn things over to Randy Cook. I presented with him before. He's very sharp. He knows his stuff. He speaks well, and that said, I'm going to go ahead and turn this over to him. So let me give Randy the mouse. Oops, there's Randy Cook's screen.
Hi guys, everybody hear me okay?
Yes.
Thanks, Jeff, and thanks for allowing me to talk a little bit about what we do. As you can see, I fit real nicely in with the Soaring Eagle methodology and mindset. My background before I jumped into the Flash world was being an Oracle database consultant, and it was all about performance. It was all about those trouble calls out there that you just mentioned, Jeff. Oh my gosh, my database has come to a screeching halt. Someone please come help. So that's what I did for a long time. And then one day I was approached by the CEO of the Flash company, and it just kind of made sense because, like you just mentioned as well, so much around database performance, application performance is how do you store the data and how do you get at it. And that's where we just started. I started to get into the Flash mentality and the Flash methodology about 6+ years ago, and I've just had a blast doing it. I quite often get brought into pre-sales calls with customers, potential customers that are explaining to us that their Oracle database, their SQL Server, whatever is very slow, and we think it's the storage. And as you just talked about in great detail, Jeff, part of that big bang for the buck is getting in there and being able to identify what their problems and as quickly as possible and fixing it, because most of the time all of the magic smoke is being let out of their boxes and people are pulling their hair out. And as you could see from my initial picture, there's not a lot of hair left to be pulled out at my stage here. So number one driver, what do? We need more performance. We've got high performance applications that need that performance, and that's usually the major driver for someone that's looking for a Flash solution. There's all types of different things that can come into play. Less tuning, we want our environment to be easier to deal with. We want it to be plug and play. We want storage as a service kind of mentality, things like that. But a lot of the time at this point in history, it's all about, oh my gosh, we've got these applications that have to have, sub-millisecond type SLA performance, and that's why we're looking into this scenario, this solution. Performance degradation, this is what we are seeing as some of the biggest problems, bottlenecks, however you want to think about it. What are the biggest database challenges of organizations? It's performance degradation. Why is it degrading? Data is getting bigger. The data sets are getting bigger. Now we talk in terms of terabyte databases where we used to talk gigabyte databases. Everything's growing. Systems are getting bigger. Everything about it is, there's just so much more data coming into an organization that the performance starts to degrade. That's the increase in transactional workloads, too much data, storage I/O bottlenecks. These are what are causing this degradation. Those applications, those databases that were poorly tuned, before they used to be able to handle that, but they were only querying 100,000 records. Now they're querying 5 billion records. Those SQL statements are no longer functional. So some of the symptoms, you start to see the high storage latencies creeping up. In our methodology, in our terminology, we say anything greater than 2 or 3 milliseconds that the database is seeing when it requests a block of data. That's high storage latency.
Hey, Randy, I hate to interrupt, but your slides don't seem to be moving forwards.
Let's see. Are you seeing this screen?
We keep saying how to make your databases hum, but we're not moving past that slide.
Okay. Which screen is being shared? Technical difficulties all the way around, right?
That's
How about that one?
There we go.
Better?
Yes.
The previous slides were just kind of pictures of what I was speaking to, so we can kind of glance at those real quick. But this is where I was. Symptoms of the I/O bottleneck on Oracle, on SQL, on any databases: storage latency. If we start to get into the intricacies of Oracle, we got redo log and temporary object contention, writes affecting read, low throughput. All of these things have a similar background, and that is talking about that storage. It's how does our system get at the data? Where's it being stored? How are we getting at it? And how quickly can we get at it? Okay, did it go to the next slide?
I'm seeing the symptoms of storage I/O bottleneck on SQL Server.
SQL Server, same kind of concept. There's those bullets again: storage latency, temp DB contention, writes affecting read performance, low throughput. These are all those symptoms. Okay, so databases store data. That's what they do. And if at the bottom level of that, storing that data and retrieving that data is slow, then more than likely the rest of the system is just going to lag. Timid database performance, slow running SQL queries, batch jobs exceeding the maintenance windows. These are the nightmares of the DBA. So this is what Caminario, Soaring Eagle as a partnership kind of are going after. When we start hearing these buzzwords inside of meetings and pre-sales or scenarios, we start to say, okay, this sounds like a good opportunity. We're not meeting our SLAs anymore. We lost customers, we lost whatever. What we used to be able to do well, we're not doing well anymore, and nothing has really changed except we've grown. So we start to listen in on those types of things. What's hardware helping and to optimize the database? So a few different scenarios: make my database applications hum. Our objective: minimize latency. It's all about latency. We can talk about throughput and we can talk about IOPS, but without sub-millisecond latency, that timing aspect, the amount of time it takes that CPU core to reach out, grab that block of data off of storage, bring it back into the RDMS and process it, that's the latency we're talking about. So we can talk about throughput in a lot of big DSS systems and things like that where we're actually pumping and crunching a lot of data. But when we start talking about high-end OLTP type application databases, we're talking about that latency. How quickly can we get at that block of data? And I'll stop right there and say, database blocks are all kinds of different sizes, aren't they? I heard you mention that, Jeff, and it was a great lead-in. It is a different aspect to start talking about Oracle databases, SQL databases, and their multi-block sizes. Once upon a time, as an Oracle DBA, I used to say, well, my database has 8K block sizes. Well, that was true until you did a full table scan and you factor in multi-block read counts and things like that. And you can actually watch the database block sizes go from 4K, 8K, 16, 32, 64K block sizes just based on how much data the database is trying to get. So flexibility to tune performance cost, break through the storage I/O bottleneck. This is what we aim to do. This is what the paradigm behind all flash arrays is all about. Getting through the I/O bottleneck. 2 to 5 times faster. SQL, Oracle, whatever type of application, VMware applications love it. It's just about getting through that latency bottleneck. That's a picture of one of our 4U 1K blocks. So that's our building block. I think we're going to go through a couple slides that shows how we can scale up, scale out. But let's talk a little bit about predictability. I don't know if you've ever tuned a nice query for hours and hours to make it rock solid and sub-second type response time, and then something happens that's outside of the query's predictability, and all of a sudden that query goes up to 3 or 4 or 5 seconds, and which is an eternity when it used to be less than a second. So we have to have a system that's storage at the storage layer that is predictable. So it has to be, it doesn't matter if it's 50 IOPS or 50,000 IOPS, it has to be that 300 microsecond latency all the time, because as soon as we start saying, well, there's latency spikes, now we have unpredictable performance and the database is slow again. I love that terminology. The database is slow. Yeah, that's usually how the call starts. Predictable cost efficiency, data reduction, all types of data handling type algorithms built into the system should be built into the system. So compression should be a part of the picture. Data deduplication should be a part of the picture. Databases don't really dedupe very well, but they compress very nicely in a lot of cases. So that should just be there. Resiliency, you got to have a storage system that's up, and it's always up, because as soon as it breaks, you know, it doesn't matter how much money you spent on it. And a lot of organizations, an hour of downtime costs millions of dollars. So it has to be 5.9 type resiliency and always up, hot swappable, non-disruptible upgrades. These are all terms that should be asked if you're looking at a storage vendor. Management, one of the things I love saying in pre-sales and post-sales when I'm implementing our storage is your storage really needs to be so easy, even a DBA can do it. That's one of my favorite terms, because as a DBA, you know, when I was dealing back in the very complex storage arrays and things back in the day, it would take a team of storage architects hours, days, weeks, a quarter to implement a terabyte storage system. I can walk into an engagement now, take the equipment out of a box, stand it up, have it configured, implemented, the database server seeing the storage and accepting and running on the database in less than a day. So it has to be something that simple. And then once you turn that over, the DBAs have to be able to use the system, because they're the ones that are going to be looking at it saying, gosh, do I have a storage problem? And if it's easy enough to use, the DBA can actually start to use the storage as a tuning tool. You can see what the storage is doing when this query is run. Is it doing a full table scan, or is it doing an index range scan? Is it hammering the system with a lot of throughput, like it's doing a full table scan for some unknown reason, like it's missing an index? Or is it doing exactly what I think it should do? There's that magic word, right? Mixed workload processing. How many databases out there today only do OLTP? They don't do any reporting. They don't do any ETL at night. All they do is OLTP. That's kind of far and few between now. Active controllers. These are things that are inside the Caminario footprint that kind of you should pay attention to. As Jeff was mentioning, these are things that you should be saying, putting checks into check boxes when you're looking at hardware vendors, storage vendors. Adaptive block size. Okay, it does really good on 4K blocks, but as soon as I go to 16 or 32K blocks, which a lot of the databases are running on today, the performance cuts in half. That's not acceptable, because your OLTP database is going to have a different block size when it's querying those structures, those bitmap indexes or whatever, than your OLAP database doing that full table scan. Global distribution of data and metadata across all the nodes. This is getting back to that 5.9 uptime. You can't have a single point of failure. So everything has to be spread. Everything has to be, the system has to be used as a whole. Mixed workload processing. You got to have, there's just, you're not going to be able to dedicate an entire storage network, a SAN, to a single use case anymore. It just doesn't happen. There's SQL, there's Oracle, there's Unix, there's Linux, there's Windows. They're all running against the same storage systems, and they all have different characteristics. So you really have to be able to service all of those systems. Virtual versus bare metal systems. It's all going to be out there. All the data centers now are extremely complex, and the days of dedicating storage to a single application are just not realistic anymore, especially with the introduction to cloud computing and all of that stuff. It's just, it has to be able to service everything. Mixed workloads. Okay, these are real life examples. If you are dealing with a system that has a very structured block size, or it can only handle what it's specifically tuned for, and you hit it with all of these different environments, you will see latency spikes all over the place. Performance will never be linear, and you'll really never be able to tune something adequately. You'll tune to one of those circumstances, and the other ones will suffer. Talking a little bit about the underlying data handling techniques, compression, deduplication. It should be native to the hardware, right? I heard mentioning that this is one of those checkboxes that it really should be a part of the solution, not something that you have to pay extra for. So if the system comes with these things, but it's a licensable, well, that's a red flag there. They should all be something that is built into the system. You can select them or not select them based on your data types and things like that, but they are there and they're available. It's all about consolidating workflow, environment, databases, anything that you can do to make the system easier to manage, reduce the footprint, reduce the complexity. You shouldn't have to have 6 different storage architects managing your data center because of all of the different types of storages in play. Few examples. Customer who's requiring application performance. They wanted a QA refresh rate that was much more efficient than what they were doing in the past. They wanted to be able to refresh those things on click at any time that they needed to. It was consisting of SQL Server. They wanted that DR dev test system mentality, and they wanted everything built into that one predictable storage platform. So that's what they got with Caminario. Before and after. I love doing before and after slides. As an Oracle DBA, I really love to dig into the AWR reports that tell you exactly hour by hour by hour what Oracle was doing, what it was waiting on, how much it was doing its waiting, and things like that. And this is the kind of graphs that we can get out of that kind of information. It's just before the latency was spiking all over the place, the response times, SLAs were being dropped. You can see where the ETL is kicking in, and with the implementation of a K2, boom, it flatlines and basically just goes away. And it's always that way. Now you can say if you have a spike, there must be something wrong in the entire system. You can pinpoint it. You can state it's network related. We've got a CPU failure, something, because now you have a baseline that allows you to troubleshoot. More examples. Results: 80% latency improvement, right around 1 millisecond. No latency change with market events. So these are things that they were looking for. simplified operations, ease of scalability. I hope those slides are in my upcoming slides here. Let me check, because it's kind of important to understand the methods for expansion, because databases are as a DBA, I remember I used to have to always go to my storage admin and ask for more storage. We are the consumer of the disk. You know, as DBAs, we just need more. We always need more. Sometimes we would be asking for more performance. Sometimes we'd be just asking for more capacity. So your storage vendor, your flash vendor, needs to be able to handle both of those requests. So there's a concept of scaling up and scaling out. Scaling up meaning that you should be able to add capacity to your system without adding a whole bunch more horsepower. You don't need more horsepower, you just need more terabytes. Or you should be able to add more horsepower if you need it as well, because our databases grew from 4 instances to 12 instances. Our customers became bigger, whatever. You need more horsepower. You should be able to expand that way as well by getting more controllers and expanding out. So that's a key thing that Jeff mentioned on one of his last slides, is make sure that you have the ability to scale up and scale out, because you're not always going to need more performance. You could need more disk, or vice versa. So this is our partnership. I think it's a great scenario where Soaring Eagle can use us as one of their tools when they do go into one of their customers, their clients, and the client they identify as a slow storage type problem customer. It's just an easy fit. And again, we love to do proof of concepts. If there is a question that this is really going to speed up your systems as much as we say it's going to, then we'd love to do a proof of concept, and we can implement this in hours rather than days and weeks. So it is very non-intrusive to your testing methodologies. We love to get into projects. 275 employees. We're based out of Boston area. Our R&D started, and the company started in Tel Aviv. We've still got a lot of engineers over there. We've got offices, London, Paris, Seoul. Jeff mentioned support. Customer support is, to me, one of the biggest bang for the buck that you can get when you come to Caminario. We love dealing with the customers. We love helping them solve problems, and that does not stop the day that we walk out the door and you're running on Caminario storage. As an Oracle person, I'm being brought into our Oracle customers and helping them solve problems that really aren't storage related, but you know what? You're now a Caminario customer, so you get a little bit of that free Oracle consulting out of me, because you are running that on an Oracle or on a Caminario system. So the customer service is 100% better than what I was used to dealing with Oracle support and things like that. It's just night and day. So that's us. Any questions about Caminario? And I guess I just open it back up to everybody. So Jeff, you can take back over if you want.
Yeah, leave your screen up for just another minute if you would. Thank you all for attending, and thank you, Randy, for your time. If there are any questions, we'd love to field them right now. And you're also certainly welcome to reach out to us after the webinar. All right, I am not seeing anything in the questions box or in the chat box. I'll assume that we've been absolutely clear, which is great. Thank you very much, Randy. Everybody have a fantastic day, and thank you for spending this hour with us.